Thank you for joining us for this session on how the ArcGIS Runtime SDKs can be used to build solutions for the defense and public safety industries. My name is Carrie Robinson, and I'm a product owner for defense and public safety here on the development team. My job is to help coordinate and drive core capabilities in ArcGIS to meet the needs of these industries. And my co-presenter is Lucas Danzinger. He's the product owner for the ArcGIS Runtime SDK for Qt, and he's kindly agreed to help me in this presentation to discuss some top tips for developing with ArcGIS Runtime and to do a bit of a deeper dive into some code to support these topics that we talk about. So, what are some of the common characteristics of typical apps written for defense and public safety? Well, increasingly we're talking more about building mission-focused apps, moving away from those larger, several-year procurement, one-size-fits-all approach, and building more focused apps to support operations. For mission-critical apps used in the field, these typically need to be able to work in disconnected or sometimes connected environments. And there needs to be no dependency on a network or a server, so most information should be available local on the device, and only critical dynamic information gets exchanged over the network. Also, collaboration and sharing situational awareness information is key for these apps to support decision-making. So having high-performance apps is critical. The ArcGIS Runtime SDKs are particularly well suited for these apps because they allow you to build native apps, giving you the best performance and ability to leverage device capabilities. The Runtime SDKs include 5 APIs for 6 desktop and mobile platforms. We have 3 releases a year. Each are rich in functionality and include capabilities such as being able to work with local data and maps, taking your maps offline, supporting military and complex symbology, support for KML, which now includes the ability to create, save, and edit KML files. We continue to support OGC formats with every release, and we have a new way to place dynamic symbols on a 3D surface in a draped mode. We also now have subsurface visualization that I know many of you have been asking for a while. And now we also have augmented reality support for mobile platforms. And there's a lot of other capabilities that the Runtime SDKs have, but there's a lot that are particularly well suited for defense and public safety. And actually a couple of years ago, we released an open source app for developers building situational awareness solutions intended for disconnected, intermittent, and low bandwidth environments. The app is called Dynamic Situational Awareness, or we call it DSA for short, and it's written using the ArcGIS Runtime SDK for Qt. It includes best practices for key workflows such as working offline, working with near real-time data feeds, for exploratory analysis, alerts, geofencing, and some collaboration tools. It's written in 3D and includes 2 apps, one for an embedded desktop in-vehicle environment and one for a handheld mobile environment. So today, we're going to be using DSA and a few other apps to help dive into some of these capabilities during this workshop. So those capabilities that we're going to talk about, there's 4 of them. The first one is offline data workflows. So how to work with data that's, get your maps onto your device and then work with them locally. Working with real-time or near real-time, highly dynamic feeds of information, how to make that information come alive in your runtime app. We're going to look at military symbology. So there's been, we've supported military symbology for some time in runtime, but we've made some enhancements to it recently that are interesting to take a look at. And then finally, some of our exploratory visual analysis tools. And then I'll give you a little hint into some of the capabilities that we're looking at building in the future. So let's start off first looking at how we can work with various data formats stored locally on the device, or different ways that you can get your map data offline. The DSA app was written to showcase workflows where there is no access to a GIS server. So most information we're assuming is side-loaded onto the device on your file system, and it's coming in the form of a data file or a package. All right, so I'll move over to our DSA app that I have running here. So this is DSA. This is the in-vehicle version. And our scenario is based over Monterey, California. That's what you're seeing here. And the app opens with a default base map loaded. And this is a tile package that's on my device. I can choose different base maps if I'd like, but I'm going to stick with the topographic one for today. So that's kind of getting that base foundational information into the map. And those tile packages can be, it can be an online service, but they can also be deployed locally as file, in a file format. There's this add data tool in DSA that allows us to add some local file and package formats. And ArcGIS Runtime supports many, many different file formats. There's over 20 different raster file formats. We support mobile geodatabases, shape files, KML files, etc. And I'm going to show just a few of these to you today. So first, I'm just going to, let's see, I'll choose the city boundary shapefile and add that to my map. And so we see it here. Now notice it's just using a default grayscale symbology for these polygons because there's no symbology that's stored with that shapefile data itself. So we're just applying some defaults here. I can also add imagery. So I have some satellite imagery here over the area. I can bring that in and look at it. And another thing that Runtime allows you to do is to specify a raster file as your elevation source. So actually, I'm just going to move in here a little bit so you can see the 3D elevation. So we do have some terrain that's here, but maybe while I'm in the field or there's some update, some higher resolution data that's sent to me, I can bring that in and add it to that elevation surface. So I have a detailed file here, and I just need to check this box to say add it as an elevation source. And once I do that, then you can make out a little bit here about how we have some slightly higher fidelity elevation data here loaded in. So that's a handy thing to be able to do. I also want to show in DSA we have this layer list control for the overlays. So this is a good example of how you can build one of these controls. So we can turn on and off these layers, we can zoom to them, we can move them up and down in draw order, etc. And so DSA shows an example in Qt of how you might want to do that. So Runtime also supports data packages, like the geopackage format. And I can add one in here. I have some utility infrastructure data that's in a geopackage format. I don't want to add that as an elevation source. So I'll add that to my map. We'll see that even though this is a package format, it's packaging the data. So it's a good way of getting data onto a device, but there's no way to also package in the symbology or how it should be rendered or displayed on the device. So we see it's also using this kind of default grayscale symbology here. Okay. So now I will hand it over to Lucas for some quick top tips and a code example for working with local data and packages.
ArcGIS Runtime supports local data by exposing many different layer classes, all of which inherit from the base class layer. Here you're looking at the API reference for layer, which you can see implements the layer content and loadable interfaces. Layer content is what gives you the ability to change the name, change the visibility, fetch legend infos, and so on. We have explicit classes exposed for many of the layer types, including ArcGIS Scene Layer, ArcGIS Vector Tile Layer, Feature Layer, Raster Layer, and so on. Having these explicit types exposed makes it very easy to work with the data. Let's take a look at some code. In this example, we're going to work with a local tile package and display it in the map. First, we'll create a new ArcGIS tile layer by passing in the path to the TPK into the constructor. Next, we'll create a new base map by passing in the tiled layer to the constructor. And finally, we'll set the base map to the map's base map property. Now, data can also be displayed as operational layers. So in this case, we'll add some data to our operational layer list. First, we'll create a new raster object by passing in the path to a local TIFF file. After that, we'll create a new raster layer by passing in the raster object. The layer is what will handle the display of the raster file. Next, we'll create a shapefile by passing in the path to the SHP file into the shapefile feature table constructor. After that, we'll create a feature layer by passing in the shapefile feature table instance. Feature layer is a generic layer that will display for many different feature table types, including service feature table, shapefile feature table, geodatabase feature table, and geopackage feature table. Once we've created the layers, we can add those to the operational layer list by saying map.operationallayers.append and then passing in the layer instance.
So Esri also provides a way to package up data, symbology, the map, and map configurations into map and scene packages. So maps are 2D maps and scenes are for 3D data. And these are single portable files which can be used in any ArcGIS runtime-based application. I'll go back to my DSA app here. In DSA, we have a tool here that allows you to browse to any scene packages that are on the device. So there's a few that are here. I can choose this one over Monterey. And now we see that it's added a few layers to my map. We have this black areas of interest that are added in, and we have these red and yellow and orange lines here. It's a little bit hard to see, but they're actually the results of some analysis that's been performed by my GIS analyst that's showing in red the roads that have had many incidents that have happened along them. So this is important information to get to me, so I know maybe safer routes to travel while I'm in the field. And the nice thing here is that because it's in a package, the symbology for that layer has been included within the package itself. So the GIS analyst who authored it was able to configure the map exactly, or the scene exactly as it needed to be for the app. And as an app developer, I didn't have to worry about how to symbolize it. And as the app user, I don't need to worry about it either. It just works. So we can see in our layer list that this analytical layer is here and the area of interest. Also included in the package that was turned off by default is an integrated mesh layer. So this is another format that's supported by Runtime. So this is from Vricon, and it gives us really high resolution 3D content that we can use to help us, to help improve our situational awareness as we move about. So how do you create one of these packages? Well, you use ArcGIS Pro for that. And here I am in ArcGIS Pro. And you can see the data that I showed earlier. I'm in my scene. I have my count incidents by lines of communication symbolized in a specific way, and my areas of interest. And then that topographic base map is here. I also have that elevation service baked in as well. So in case I don't already have that on my device, I can include that in the package. And we have a geoprocessing tool that's called Create Mobile Scene Package. And it lets me specify the scene that I want to include. And you can include more than one scene, which is pretty convenient. So you can just create one package that has all the scenes or the kind of map views in it that you want to be able to deploy to the device. Then I just give it an output name, an area to clip if I want to clip the data, some other metadata, and run the tool, and it creates that mobile scene package. And it's as easy as that. So just to reiterate, this really makes it easy on the developer and the end user. They don't have to guess about how to most effectively symbolize the data that's in the package. So this is a really nice way to make that work. So now I'll hand it back to Lucas to talk about some code snippets that have to do with map and scene packages.
Let's take a look at how you'd interact with mobile map and mobile scene packages in ArcGIS Runtime. This specific code example will show mobile map packages, but the same workflow will be applicable for mobile scene packages. First, we'll create a new mobile map package instance by passing in the path to an MMPK file. For a mobile scene package, you'd pass in the path to an MSPK file. Next, we will load the mobile map package, which is an asynchronous task. Once this loads, we can access the list of maps that are inside of the package. For scenes, this would be a list of scenes inside of the package. Finally, we can display the map in the map view by accessing the first index of the list.
ArcGIS also provides other ways to take web maps offline. These methods are better for clients which are more occasionally connected to a network or to a server that's hosting that map data, whether it's ArcGIS Online or ArcGIS Enterprise. And we're going to show you a few of these ways. So if I go to my browser, I'm in ArcGIS Online now, and I'm looking at a web map of some data that's over Monterey where I'm working. Now, I want to be able to allow this map to be taken offline. So in this case, in the last case, I was showing you using ArcGIS Pro to author a map that you then create into a package. This is slightly different in that I'm authoring a web map in my portal, and this map is a live map of data that can be taken offline periodically when it needs to be. But there's a few things you need to do in order to make sure it's enabled for offline use. So here's the Details tab for my web map in Portal. And we can see I have a few layers here, areas of interest, some observers, and I have my base map. The first thing to note is that the base map must either be a tile layer that you're hosting in your environment yourself, so it's okay with you that people can take that offline. If you want to use an Esri base map, there are a set of base maps that can be used for export purposes, and so you can find those and you can bring them into your map, and then the tiles that can be taken off of those base maps when requested. So for feature layers that are in your map, for instance, I'll look at this area of interest one here. There's a few things you need to know about making sure that these kinds of layers can be taken offline. So if I go into the settings and into feature layer, the main thing you need to do is to check this box for enable sync. That's the bare minimum that's required to allow that layer to be taken offline. If you want to enable other workflows such as editing, then you can check this box here, and then there's a lot of other options you can choose depending on what your editing workflows are. In this case, I don't want to enable editing. I just want to make sure that I just want to say it's okay for this to be taken offline. So once I do that for all of the layers within my web map, when I go into my web map settings, there appears this option for offline settings. That offline settings does not appear if all of the layers in your web map are not configured for offline use. So if you don't see it, it means you have to go back in for each one and follow the instructions that we outline in our documentation to make sure they can be taken offline. So that's a little top tip from me. So in these settings, I can toggle to enable this offline mode. And now that's the bare minimum I need to do for the web map. So now when any ArcGIS Runtime app connects to this web map, it'll see that it can be taken offline. So I'll show you an example of that. Actually, I'll go back. I need to copy the URL of this web map to show in this example. So this is just a test app that we use internally for working with offline data. So I have to paste in the web map URL here. Typically in an app, you would allow the user to browse to the map they want to use. But what it's doing now is it's understanding from the web map what its capabilities are. And we can see a live version of the map here. And then on the left-hand side, we get some of that metadata about it. And because we see that it's been enabled for offline use, we have some tools that we can use to take it offline. And the first one I'll show you is the on-demand workflow. And on-demand means that the client can make the request for the area that needs to be taken offline. So in this case, I'm using this client app in Runtime. I can draw an extent here, and I can tell the server that I want to take this data offline for my use. So while I'm still connected, I make this request. And because I already have base maps loaded on my device, I can uncheck that I want to include the base map. So it should just grab any of the other operational overlays that are in my map. There's many other settings that you can choose here that's available in the API, and I don't really have time to go into them. So I'll just show just the defaults essentially. And now what it's doing is it's going to the server, it's requesting that it package up the data that's within the specific area of interest that I've specified, and then it's downloading it to the device. And so now that it's downloaded, I can open it up, and we see that it's really just those observation towers, because I explicitly asked it not to include the base map, and there were no area of interest polygons within the area that I specified for download. So that layer is there, there's just no features in it. If I had enabled it for editing, I would be able to add those new features, and that would be okay. So that's the on-demand workflow. But you might imagine that if you had several people using your app that were maybe signing into work at the same time in the morning, and they all want to request to take very similar areas offline at the same time, it puts quite a heavy load on the server to dynamically package up that data and make available, because it would do it for each one of those users. That doesn't make the most sense for that scenario. So we have another option called Preplanned maps. And so back in my web map settings here, under map areas, there's a little button to manage your areas. And this allows you, as the author of the web map, to predetermine specific areas of the map to take offline. So I've already created 2 of these here, but it's a very similar process to what you saw in the client application. You're just doing it on the server. You specify an area, and then you can tell it which levels of detail you want to be able to take offline. You can also give it a schedule for updates. So maybe you know that the data changes on a daily basis, so at midnight you'll always refresh and update that this map area, or on a weekly basis, or whatever it might be. Or maybe it's always static, so only create it once and that's it. Whatever suits your workflow. The other thing with those updates, or those the updated packages, is it runtime knows to only download the deltas. So if there is an update to your package, the runtime application will only download the changes. It won't have to download the whole thing every time, which is great. So I have a map area that's already here that includes the base map and these 2 layers, although this red one is still only including there's only features from the observation towers there. Now that those are there, if I go back to my runtime app, I can see that there's this download pre-planned map area option. So the API can query the map. It sees that there's these 2 areas that are ready for download. I'll choose area 2. There's several parameters you can provide that I don't have the time to go into the detail. But I can ask it to download that map area, and it's much faster than the previous one because all it's doing is downloading it. The server doesn't have to create that map area dynamically. And now that it's downloaded, I can open that, and we'll see that just that clipped area of the topographic base map is there, along with those observation towers. So that's a pretty quick summary of how we can take maps offline. I'll hand it back over to Lucas now to show you some of the code behind this, how this works in the Runtime SDKs.
Let's take a look at some code examples for how you'd work with offline maps in ArcGIS Runtime. First, we're going to look at the pre-planned workflow. For both the pre-planned and on-demand workflows, we'll be using the offline map task class. First, we're going to create a new offline map task instance by passing in a web map to the constructor. Next, we will load the offline map task. Loading will initialize the task asynchronously and retrieve all of the different resources that are needed to execute the task. Next, we will request all of the pre-planned areas that have been authored with the map. This is an asynchronous task as well. Once that completes, we'll get a specific map area out of the list. Next, we will request the default parameters from the offline map task, and this will generate all of the defaults asynchronously, and you can then modify any of the parameters that you want to suit your needs. Once you have the parameter list, you can call offline map task.download preplanned map area, pass in your parameters, and a download path, and that will return a job. The job can then be started, which is asynchronous, and once that's complete, you will be returned an offline map which can be displayed in a map view. For on-demand, as I mentioned, you will still use the offline map task. In this case, you'll construct the task in the exact same way. You'll pass in a web map instance, and again, you will load the task. Once the task is loaded, you'll create default parameters by passing in an area of interest and a scale. In this case, the area of interest can be either an envelope or a polygon. Polygon is especially useful if you are generating offline areas that follow a route. This can massively decrease the amount of tiles that you'll need to take offline, which will decrease the overall size of your package. Once you have your parameters, you can call generate offline map job and pass in the parameters and a download path. This will return to you a job, and the job can be started. Again, this is an asynchronous task, and once it completes, the offline map will be returned and you can display the map in a map view.
Okay, so next we're going to talk about real-time and dynamic data. In these types of applications that we're talking about, it is critical that you're able to share situational awareness and that you can collaborate in near real time with your teammates in the field and back in the headquarters or the command post. And typically this kind of information is shared in smaller packets of information over more low bandwidth networks like tactical radio networks or peer-to-peer networks. And this information is highly dynamic. In DSA, we show you how you can work with this information that comes in packets over the network. But we don't show you how to build that communication network. We really focus on, once you receive it, how you can get that message of information, parse it, and then really make use of it in the app, display it properly, make sure that it updates quickly, all those sorts of things. So if we go back to our DSA application here, there's a little feeds tab here, and I can turn on some feeds. So we have some that are being simulated at the moment on my machine, showing a couple different pieces of information. So the blue symbols here are all friendly forces, so these are my teammates in the field. We show some that are reporting their positions on the land as they're moving about. And we also have this one little drone that's flying along here as well that we can see its absolute position rendered on the scene. We also have another layer here for some observations and some sensor reports that are being made in the field as well that can pop up here. So these are fairly dynamic feeds, but for things like these position reports, the information doesn't necessarily change, but the position might. So runtime is highly suited for these dynamic environments where you're receiving information and making updates to it in near real time. So I'll hand it back over to Lucas now to show you a little bit more about some best practices and how this is done.
So let's take a look at how you can accomplish real-time feed functionality in an ArcGIS Runtime application. First, we'll cover some top tips and the runtime APIs that are used, and then we'll go into some code examples. For the top tips, first would be to display your data using a graphics overlay, because this is what's best for working with transient information. If you need data that's going to be persisted, that should be done using a layer type like feature layer, for example. In this case, we'll be getting data in, we might want to update it, and then we might want to dispose of it. This is best suited for graphics. When you're working with graphics, you can choose between two different rendering modes, either static or dynamic. Both have their use cases depending on if you have a lot of different data with different symbology, and whether the data is moving or not. But in this case, you'll want to enable dynamic rendering mode so you have smooth animations and optimized performance. The next tip is to set a render on your graphics overlay. Graphics can optionally contain the symbol itself, but it's more optimal to apply a render to the graphics overlay. This reduces your memory footprint, but it also simplifies your code because you don't need to be managing all of the symbols at the individual graphics level, and instead manage it at the renderer level. Another tip is that if you need to update a graphic, you can simply update the geometry and attributes directly on the graphic instance. You don't need to create a new graphic and add and remove the old one. You can simply update the same one because it's using a reference semantics. Finally, it's important to note that you can use graphics from your different feeds in your different analyses like line of sight and viewshed. We'll talk about that more later on in this talk. The key APIs used in this example are graphics overlay, again setting the dynamic rendering mode, and the dictionary renderer, which will give us our military symbology. Let's take a look at a code example for working with real-time feeds in ArcGIS Runtime. In this example, we're going to first create a graphics overlay using the default constructor, and next we'll set the rendering mode to graphics rendering mode dynamic. In this scenario here, we've got an event handler for onNewMessageReceived, and that will take in a point and an attribute map. This onNewMessageReceived event handler could be responding to UDP packet updates, WebSocket updates, or some other mechanism. Inside of this, we will create a new graphic every time this emits. The graphic will be updated with geometry and attributes, and then the graphic will be appended to the graphics overlay.
All right, so the next topic we're going to talk about is military symbology, and specifically how you can use it in ArcGIS and ArcGIS Runtime using dictionary symbology and dictionary renderers. We just saw an example in DSA with the live feed of using military symbols on those messages on our Blue Force friendly reports that were coming in. But I'm going to show you another app with a slightly different set of data. So this is an app that's written using the Qt SDK for runtime, and it's showing feature layers. So we're drawing more static feature layers. It's a military overlay. It's being displayed using the US Military Standard 2525 Delta. And some of you might not be familiar with military symbology, so I'll just describe it pretty quickly here. These are pretty special symbols. And that's because they relay a lot of information in one symbol. And military staff are trained to understand what that is. And so, there's no need to click on the symbol to find out more. Just by looking at it, there's lots of different ways that it can indicate to you what it's trying to relay. So for instance, the blue color always indicates that it's friendly, as opposed to red over here means hostile. So these are probably reports that are coming in of some enemy situations that are occurring in the area. The rectangular shape does indicate that it's a land unit. This shape over here indicates that it's an air unit, so this is a helicopter that's flying overhead. And then we also have these lines and areas that are here too, and these are control measures that indicate what the movement should be and what the plan is for movement of the forces themselves. So this is just a simple example of what a military overlay might look like. And there's different ways that you that can help drive the symbol. We use a dictionary symbology approach for military symbology in ArcGIS, and that means that the attributes of the data actually drive the symbol itself, which is useful because there's a lot of information that's being shown in these military symbols. And so ArcGIS provides dictionaries for for many of the US and NATO symbol standards. And there's two different ways that you can specify what the symbol is. And the first is using a symbol ID code. And this is part of the military specification. And depending on which version, it's a set of 15 or 20 or some specific number of characters where each one of those characters in the code identifies a different characteristic in the symbol. And so this is a really handy way to exchange information between systems. Just according to the standard, you get that symbol ID code, and any system knows how to render it on a map, which is obviously very important in these kind of applications. But if you are a human, perhaps, and you don't know what the symbol ID code is, or you're just receiving reports, text documents or things that have information, you can use other attributes to drive the symbols as well. So it's one or the other. And then you might have other attributes that drive other aspects of the symbol, like amplifiers around the outside, like the text that we see in some of these unique designations, the echelon, the altitude, all of those sorts of things are additional fields that you can use to drive the bits that go around the outside of the symbol. So that's how the dictionary symbology works. The other thing to show that we can do with dictionary symbology is also enable some configuration parameters or properties. And these are on the dictionary style themselves. So, and the ones that we make available for the US military standards are actually part of the specification. So we have ways to allow you to change the color scheme that's used. So you might want a darker color because you're working in more of a daylight environment that you need to see it in. You can choose whether or not to include the icon in the frame, turn the text on or off, etc. So those are all configuration properties that you may or may not want to expose to the end user of your app, but as a developer are made available to you through the API, which can be quite handy. So I'll move back to the slides real quick. So just to reiterate, we do include out-of-the-box dictionaries for the US and NATO standards, and you'll see the ones that we support listed here. For ArcGIS Runtime, we continually update these styles. So if there's, we either enhance them with new capabilities or we fix issues. Maybe if there's something that we need to fix, we can update the style with that. So the latest version is always available on this web page here that you can get to, esriurl.com/milsymbolstyles. And we also have the past versions of the style if you're working with an older version of Runtime. So that's the place to go to find the styles, and you download them, and then that's a resource that's available to your app that you can use. The other thing I wanted to mention is that we now do also officially support customizing dictionary styles. So many of you maybe want to use a US or NATO standard, but you want to add some additional symbols to them, or maybe modify them or tweak them a little bit. We now allow you to do that, and we have some tools to help you. You do this in ArcGIS Pro, and we have a dictionary toolkit that provides lots of tools and examples and some really nice documented workflows for doing this. And it's a GitHub repo at the URL that you see here. So if you're interested in doing this, or if you're even just interested in understanding a little bit more of the specifics of how these dictionary styles work, I highly recommend you go to this URL and take a look. There's some really nice information there for you. So with that, I'm going to hand back over to Lucas, and he can show you about how you can use the dictionary style and the dictionary renderer in ArcGIS Runtime.
Let's take a look at how military symbology comes to life in ArcGIS Runtime. The first important thing to know is that Runtime uses the same style files and dictionary renderer that are used in ArcGIS Pro, so the workflow is largely the same. Dictionary renderers can be displayed with either graphics overlays or feature layers, which means it can work for your temporary data coming in through real-time feeds or your persisted data. The dictionary renderer will automatically display the proper symbol for you depending on the attributes of your data. This means it's very important for you to format your data with a well-known standard. For example, you could use a set of attributes to represent your symbol, or a symbol ID code. If you prefer, you can optionally fetch symbols directly from the style file instead. This will allow you to pass in key value pairs and get back a symbol instance, which you can then use to display on a graphic. Some of the top tips are that you should let the renderer do the hard work for you. While you can fetch symbols individually, it's much easier to format your data properly and let the renderer do the hard work for you. Another top tip is to author mobile map packages. This will simplify your app code and maintenance as well. Mobile map packages fully support the dictionary renderer, so you can simply author the data in Pro and it will look the same in Runtime. Additionally, you can configure with out-of-the-box options. These are options that you publish in Pro, or customize further using Arcade. The runtime APIs that are used include the dictionary symbol style and the dictionary renderer. Let's take a look at the most basic workflow with the dictionary renderer. First, we're going to create a variable pointing to the path of the mil2525d style file. Next, we're going to create a dictionary symbol style instance by calling the createFromFile static function. In this, we pass in the path to our style file. Now that we have a dictionary symbol style, we'll create a new dictionary renderer by passing in the instance of dictionary symbol style. After that, we will get our feature layer and set the renderer property to the dictionary renderer that we just created. The bottom 3 lines of code show how you can search for a specific symbol on the dictionary symbol style. This is a useful workflow in the case that you don't want to use a renderer, but you'd rather just get the individual symbol instance. In this case, we know the symbol ID code, so we simply call fetchSymbol and pass in key value pairs for the field and attribute value that we're looking for. This will return a symbol, and we can display the symbol on a graphic. Now the dictionary renderer is set up to look for very specific fields depending on the military symbology specification that it's using. For example, if you're working with mil2525C, you might have a symbol ID code, or if you're working with mil2525D, you may have a set of attributes that define what the symbol should look like. However, sometimes the data that you have may not reflect what the renderer is looking for. In this case, we'll use attribute mapping to tell the renderer what our data looks like. So we'll start out by creating a new dictionary symbol style with the path to a style file. Next, we're going to create symbol field and text field overrides. These are key value pairs that tell you what the dictionary renderer is looking for and what our data actually has. In this case, we know that the dictionary renderer is looking for a field name SIDC, and this is for a symbol ID code. This is when you want to simply pass in a single code instead of a series of attributes. In this case, the value of our data is actually SIDC2525D. So we're going to set up this key value pair to pass in to the dictionary renderer. Just the same, we're going to set up attribute mapping for the text fields. We have quantity. In this case, quantity is what the renderer is expecting, and our data actually has quantity as well. In this case, that would not be required for you to remap it since it does match already. But unique designation right below it, the full name is unique designation, but our data is using a shapefile, so the field name was truncated to 10 characters. In this case, we need to tell it that unique designation is actually unique desi in our code. Then we'll pass both the symbol field and text field overrides into the dictionary renderer constructor and display the renderer in the feature layer. The same workflow will work if you're not using symbol IDs, but if you have attributes instead, such as when you're using mil2525D. You can see here that we're specifying the context, identity, symbol set, status, and so on. And this will give us the same output as with using the symbol ID code. Now, if you think back to Carrie's demo, we were able to showcase how you can use configurations to change some properties of the military symbols, and these are according to the specifications. For example, you might want to change between light, medium, and dark colors, or you may want to toggle text on and off. Let's take a look at this in code. Again, we'll create the dictionary symbol style from the style file path. This style file will contain many different configurations, and this will return to you a list. We can loop through the list of configurations. In this case, we're looking for a specific configuration where the name is colors. We're going to print out the different domains, and the domains are the options that you can set. In this case, for colors, we can set light, medium, or dark. To modify it, we can simply call configuration.setValue and pass in one of the domain values, for example, dark. This all works by reference, so you simply call setValue on that same configuration instance and everything will update for you.
All right, thank you, Lucas. So finally, we're going to talk about exploratory visual analysis. And these are tools introduced in ArcGIS Runtime a few years ago that use the GPU on the device to calculate visibility on the fly. ArcGIS Runtime supports two of these analysis tools, Viewshed and Line of Sight. And we call these exploratory because they use the level of detail that's drawn by the GPU on the GPU on the display. So they're not run against the source resolution of the data. And that's what gives us that really quick analysis result. I'll show you an example of this on my phone. So this is the DSA app. It's running on my phone, so it's the DSA handheld version of the app. The UI is just slightly different from what you saw earlier. And we have our analytical tools here at the top. We have one for Viewshed. And the app provides several ways to draw viewsheds on the map. So one of them is follow touch. So I can drop a viewshed on the map there, and then as I move my mouse around the display, you can see the viewshed update. And so this is what I mean about it using the GPU. It can provide that feedback really quickly. So it's good for exploring and determining what areas are visible and not visible. And in this case, I chose a 360-degree viewshed. Now, I'll go ahead and save that. And saving that really means that it's now available as an analysis overlay in my app. So we see we have this analysis list here. I can go back in and I can turn on and off that viewshed overlay if I want to, or I can remove it altogether. So the API allows you to manage all of these analysis overlays as you create them. So that was one viewshed, and that's an example of a location viewshed, meaning we're just giving it a location, a coordinate, and it's dynamically, as we update that location, it updates the viewshed accordingly. There's another type of viewshed called a, just finding my location here, called a GeoElement viewshed. And so in this case, you can attach it to a feature or a graphic on the screen. So I can, in this, here I'm attaching it to my current location, which is a graphic that's moving along the map. And this means that as I update as my position updates in the map, that viewshed automatically gets updated as well. As a developer, you don't need to add any additional lines of code to do that. It's just attached to that GeoElement as it's updating. The other thing I'm showing here is that it doesn't have to be a 360-degree viewshed. It could be smaller than that. So you can change the angle, the vertical angle. There's several settings that the API allows you to change. The colors can be changed. It doesn't have to be red and green color as well. So if I save that, then I now see that I have these two viewsheds in my app. So that's viewsheds. Actually, I'll turn off both of those. We also include a line of sight tool, and there's several ways that you might want to use line of sight in your app. The one that we've built into DSA is a pretty specific one. So it allows you to choose a point layer that's in your app, and then it shows you when you're visible to the current location. Oh, that's why it's not working. I didn't have the checkbox on. So once you do that and check on the checkbox, then it'll show you when you are visible to any of those observation towers, which are these points, these 3D points that I have in my map display. So we can see, visually, we can see that there's only one green line, which means I'm only visible by one tower at this point. You can also see at the top it says visible by one observer. So the API allows you to understand when the target is visible by the observer with any one of these lines of sight. The other thing that you'll notice is that the lines of sight are disappearing a little bit, and that's because they are just going, they're just straight sight lines that are going through the terrain. So that's why we don't see the full line. So that's how lines of sight work, and if we go into our view list, we can see that there's several of them listed here. So you manage each one of those separately. Okay, so that's an example of how you use the viewshed and the lines of sight analytical tools in DSA. And I'll hand back over to Lucas for one last time to show you how simple the code is actually for working with this data.
Here are some code examples for exploratory analysis in ArcGIS Runtime. The first we're going to look at is line of sight. To create a line of sight, we'll first create two different points, an observer point and a target point. Once we have our points, we can create a new location line of sight by passing in both of the points. Next, we'll create an analysis overlay, and the analysis overlay is what will hold on to all of our different exploratory analysis that we're creating in our application. Next, we'll append the line of sight to the analysis overlay. After that, we will append the analysis overlay to the scene view. And finally, we can access whether the target is visible or not by accessing target visibility property. This will return to you an enumeration that will let you know if it's visible, obstructed, or unknown. Viewshed works very similarly, but instead you only create one point, the observer point. Additionally, you'll create several different parameters to define the frustum outline of what you're looking at. These include the heading, pitch, horizontal and vertical angles, and the minimum and maximum distance. You'll pass all these different parameters into the location viewshed constructor, add the viewshed to analysis overlay, append the analysis overlay to the scene view, and this will give you the output viewshed on your scene view.
Okay, so we only had an hour for this workshop, so we only were really able to dive into those 4 areas. There's lots of capability we'd love to show you. Hopefully that was helpful for you and gave you an overview. There's several other sessions that are being made available that go into a lot more detail in some of these areas. So we highly recommend that you take a look at some of those, in particular ones that have to do with the offline map workflows. We have several sessions diving into those ways to perform analysis. We have details on each one of the Runtime SDKs, so I encourage you to take a look at those other workshops if you haven't already. The other thing I wanted to do was show you how to find some of the resources that we've talked about and some additional resources that might be helpful for you. So I'm back in the browser now. The first one, and the main one really, is the developer site. And if you haven't been to this lately, or if you've never been to this site, please go visit it. It's really a great site. We have a team of people who are updating it constantly with some really great content. It's pretty amazing. If I scroll down a little bit, there's this first section that you see here that lets you explore some of the capabilities of ArcGIS. And it's nice because it describes it from a somewhat generic point of view and then allows you to dive into the aspect of ArcGIS that you're using, which is really, really good. So for instance, there's a section here on offline workflows. And if I just move to that page, we have a really nice description of some of the ways that you can take maps offline. So we have links here to other pages that talk about that. We have several tutorials and then some other pieces of information that you can use depending on what you want to do. So if you do want to enable editing, there's a link here and some tutorials to talk about editing. So definitely make sure to spend some time poking around this developer site and see if you can find the information that you need. In terms of the DSA app, how you find that is you go to the documentation tab, and because it was written with the SDK for Qt, you go to that documentation page. So I'm now in the Runtime SDK for Qt page. Just scroll down a little bit, and one of these tiles here is for open source apps. So if I click on that tile, then it brings me to the open source app page. And so we have several open source apps that we've built. And the DSA app is one of them. And from here, I can go into the DSA page and get a nice summary of everything that the DSA app does, some of which we talked about today. And at the bottom here, it provides a link to the source code. And that link brings you to this GitHub repository that has everything you need for the DSA app inside. On the main page, just take a step back here. On the main page is a README that gives a little bit more information and shows you how to get the code and install it. It takes advantage of the Qt SDK toolkit. So that's another thing you need that you can take advantage of in the app. So make sure you read those instructions. But if you want even more documentation and more information about the app, you can just go into the docs folder here, and there's a nice markdown folder here that has a lot of information in it. And I'm actually going to scroll all the way down to the bottom to this section here, get the DSA apps. One of the other things that we're doing is we're providing these apps as binaries that you can download and try out yourself for Windows and Android. So if you just want to see the app and see how it works, you're more than welcome to download these apps and give it a go. You shouldn't use them for production purposes. It's not meant for that. So this is just to see what the Runtime SDK can do. And then we encourage you to get the source code and try and build and configure the app for your own purposes. And it does include some local data. It also includes the simulator for the real-time feeds. So this is where you find that information, is here in the GitHub repo. So that's how you get DSA. Now, just to wrap it up a bit, here's some of the capabilities that we're working on this year that you might be interested in. 100.8 is the next version of the Runtime SDKs that will be released next month in April. And one of the things that we're adding is the ability to work with image overlays. So image overlays means what we're intending here is the use of highly dynamic image data that might be coming from like a radar feed. So we have a couple of examples that you can see here. So where you get frequent updates, sub-second updates of these images that need to be refreshed and drawn on the map. So that'll be pretty cool for some of you who have that kind of data. We also are adding the ability to include online services in your mobile map packages. So there might be some workflows that you have where you want to do this, such as including highly dynamic data. If you know the app's going to be working in sometimes connected mode, you can include weather data, for instance, in there, or last known location positions, those sorts of things. Also, maybe you have some really high resolution and nice imagery, aerial or satellite imagery data that you want to make available when needed in the app, but it's way too big to include in a package that can be downloaded and deployed offline. So in that case, you can just include maybe some of that data in the package, but then a link to that online service that you always get the latest information, and you can move into other areas and get that imagery data as well. So that's coming in 100.8. There's also a lot of work that we'll be starting in 2020 around these areas that you see here on the right-hand side. So we're continuing to add capabilities to the Runtime SDKs. There's a lot of work we still have to do. And I'm interested to hear what you're particularly looking for. So that's all we have for today. Thank you so much for joining us. Hopefully you got a little bit out of the session. If you have any questions, please feel free to contact myself or Lucas. Our email addresses are here. Also, if you just have questions in general about the Runtime SDKs, there's a GeoNet forum for native apps, and then ones for each one of the Runtime SDKs. So you can get to that by going to esriurl.com/geonetnative. And then find a forum or ask the question that you'd like to ask. And there's several people monitoring those forums who should be able to get an answer right back to you. So again, thank you very much for joining us, and hope you have a wonderful day.